of theta. Now, any point on this unit circle is going to have coordinates cosine theta, sine theta. So we can give the coordinates with the Cartesian system, x, y, with numbers, but on the unit circle we can give those coordinates of any of those points with trig functions. Cosine of theta for the x coordinate, sine of theta for the y coordinate. But let me remind you that on the Cartesian coordinate system we can have negative values of x anywhere to the left of the y-axis. We can have negative values of y anywhere below the x-axis. That's what this table right here shows us, that in quadrant 1 x is positive, x values are positive, y values are positive. In quadrant 2, x values are negative, y values are positive. In quadrant 3, x values are negative, y values are negative. And in quadrant 4, x values are positive and y values are negative. So, this means that when we have an angle, which we can't have in a right triangle, when we have an angle that exceeds 90 degrees, say it goes out here, now let's say that instead of having that angle, we have a new angle in standard position, measured from the x-axis counterclockwise to the terminal ray. That point where it hits, where that ray intersects this unit circle, is going to have coordinates cosine theta, sine theta for x and y. Now, this is interesting. That means that our x values are going to be in quadrant 2 negative. So the cosine of an angle that is more than 90 degrees but less than 180 degrees, somewhere in the second quadrant, this is going to be a negative value. Okay? So, we could replace x and y with what they equal in terms of our new definitions here. Cosine theta and sine of theta are equal to x and y respectively. X equals cosine theta, y equals sine of theta. So now, the cosine of an angle that in standard position, whose terminal ray is in quadrant 2, is going to have a negative value. Well, that makes sense, because if it's our x-coordinate, that means that we've gone this far in the x direction, which is negative. Now, I dropped this perpendicular line, this line that's perpendicular to our x-axis, and it makes this triangle on this side. Now that triangle in space still has positive dimensions, right? This is a distance, it's positive 1 because it's the radius of our unit circle. This is a positive distance. This is a positive distance. But because we've located it on our Cartesian coordinate system, that positive distance is going in a negative direction. Okay? So, this distance is equal to the cosine of this angle over here. We'll call it angle psi. It's another Greek letter. So this angle psi, cosine of that angle is this adjacent length divided by 1. The unit circle's radius, 1. So that distance is cosine of psi. And that distance, that x coordinate, so the negative version of this is going to be the x coordinate. So negative cosine of psi is going to equal what we said that the x coordinate has to equal, which is cosine of theta. Okay? Now this is interesting. This is interesting because it shows us that if we can find an angle that corresponds with an angle psi that corresponds with the actual angle we're interested in, which is theta, that we can figure out that distance that we want using a right triangle, which we're familiar with, even though we're looking for the cosine of this angle that can't possibly be in a right triangle because it's obtuse. Okay? This is good. We're getting somewhere. So, this has a special name, just the angle psi. The angle psi is a reference angle. Okay, reference angle. Psi is a reference angle to theta. All right. Now, there's quadrant 3, we'll get rid of that. So, psi is a reference angle to angle theta. What that means is, we can find that, right? We've made a straight line. Psi plus theta is 180 degrees, or it's pi radians. So, we can easily find out what our reference angle is, and that will be an angle inside of a right triangle that we can use to find our positive x distance, the distance we've gone from the origin. Now we know it's negative because we're moving to the left of the y-axis. So, psi is going to equal pi minus theta in radians, or 180 degrees minus theta when we're in quadrant 2. So this is all for quadrant 2. Now, it's a different story when we get down to quadrant 3, but we'll pick it up there next time. Hope that was helpful so far. We've got more to do. See you next time.